Hello guys, welcome to System Cog YouTube channel. Today I will be starting a new series on interfacing Bluetooth module to a PIC microcontroller. This series will be having 3 different videos. The first video, which is this, will be talking about the concept and the simulation of this project, while the second video will be all about the coding and transferring the hex file to the microcontroller. Then the last video will be the demonstration and implementation of the project. There are 2 major components we'll be using in this project: the PIC microcontroller and the Bluetooth module. The model of the Bluetooth module we'll be using is the HC06 module. This module has 4 major pins: the VCC, the ground, the TX, and the RX. The VCC and ground is used to supply power to the module, while the TX and RX is used to establish a communication. This module uses the UART serial communication. That is, the TX is used to transmit data to another device that supports the UART serial communication protocol, while the RX is used to receive data from another device that supports UART serial communication protocol. In our case, we are going to be using the PIC microcontroller to establish that communication. So the model of the PIC microcontroller we'll be using is the PIC 16F877A. This microcontroller supports the UART serial communication protocol. That is, it has the TX and the RX. For we to be able to establish a communication between these 2 devices, there is a certain kind of connection we need to establish here. First of all, the ground of both components must be connected together. The ground of the Bluetooth module and the ground of the PIC microcontroller must be connected together. Now, the TX of the Bluetooth module will be connected to the RX of the PIC microcontroller. That is to say that when we are transmitting data from the Bluetooth module, it goes to the receiver of the PIC microcontroller. And while transmitting data from the PIC microcontroller, it goes to the receiver side of the Bluetooth module. Also, a very important point you need to consider while doing this connection is the TX and the RX pin of the HC06 Bluetooth module uses 3.3 volts. Now, it is safe to transmit a 3.3 volt to the RX pin of the PIC microcontroller. So this connection is safe, but is not safe transmitting a 5 volts from the PIC microcontroller to the RX pin of the Bluetooth module. So we have to find another approach to get this connection done. There are different ways to fix or solve this problem. We can use a shift level converter, or we can use a voltage divider. The voltage divider is what I'll be using in this video. So the voltage divider simply consists of 2 resistors. Let's call this the R1 and the R2. This pin over here will be connected to the transmitter of the PIC microcontroller, while this pin over here will be connected to the receiver of the Bluetooth module, while this pin over here will be connected to ground. Remember, the TX of the PIC microcontroller supplies 5 volts. So for we to be able to get 3.3 volts at this terminal, at this point, we need to use a specific resistor value. So for R1, I'm going to use 1.8K. Then for R2, we use 3.3K. Now, to be able to find the voltage across Rx, that will be equal to R2 all over R1 plus R2 times 5, which is voltage across the TX. So here we are going to have 3.3K all over 1.8K plus 3.3K times 5. This is going to give us 3.3K all over 5.1K times 5. So our answer is 3.235 volts. That is, the voltage across RX is approximately 3.23 volts. So whenever the transmitter of the PIC microcontroller transmits a 5 volt, the receiver side of the Bluetooth module receives 3.3 volts. So let's quickly draw the complete diagram of how this whole communication will be established. So right here we have the Bluetooth module. This is HC06, that is the Bluetooth module. Then over here we have the PIC 16F877A. So here the ground of the Bluetooth module will be connected to the ground of the PIC microcontroller. Then the TX of the Bluetooth module can be connected directly to the RX of PIC microcontroller. Then the RX of the Bluetooth module won't be connected directly to the TX, or rather we are going to use a voltage divider to bring down the voltage to 3.3. Then this will be connected to ground. So this RX will be connected to this terminal. Remember, this is R1, this is R2. R1 is 1.8K, while R2 is 3.3K. So this terminal over here is going to give us approximately 3.2 volts. So with this connection, the both devices are safe. The Bluetooth module is safe to take 3.3 volts in the receiver pin, and the PIC microcontroller is safe to take 3.3 volts at the RX pin. So connecting both devices like this, we've been able to establish a communication between the PIC microcontroller and the Bluetooth module. After establishing a connection between the Bluetooth module and the PIC microcontroller, there is still a block of communication that we need. We need to be able to send data to this Bluetooth module. So what I have done is I have designed a mobile application using Flutter. So this mobile application helps to connect our phone to the Bluetooth module, and after a successful connection we will be able to send or transmit data to the PIC microcontroller. So this mobile app, I am going to make it available in the last video of the series. So let's move on to the simulation in Proteus and see how this whole thing works. Here in Proteus, I have already designed the circuit. Here we have the PIC microcontroller, the COMPI, which is representing the Bluetooth module. We have the receiver and the transmitter virtual terminal. The receiver virtual terminal shows the data that is being received in the microcontroller, while the transmitter virtual terminal shows the data that is being transmitted from the microcontroller. So at the right hand side of the circuit, we have the control unit. So the aim of this project is to be able to control load using the Bluetooth. So here we have two loads, the first load and the second load. So what I did here is, if one is sent to the microcontroller, it's going to toggle the first load. That is, one turns the first load on and off. Likewise for the second load, 2 turns the second load on and off. So I have already written the program for this project. As you can see, the hex file is already available. So what I'm going to do right now is to run the simulation and test it out. So I'm going to click on play. So as you can see, the virtual terminal for the transmitter is showing HC06 ready. So what I'm going to do now is to open the PuTTY software. I'm going to set this to serial. The COM port number I'll be using is 2. And my baud rate is 9600. So I'm going to click on open. So over here, I'm going to send 1 and 2 to the microcontroller. As I'm doing that, pay attention to the receiver. You see the data that has been received to the microcontroller will display on the receiver terminal. While also you pay attention to the load. Whenever I send 1, it turns on the first load, and if I send again, it turns it off. Likewise for the second load, 2 turns it on and off. So let's get started. As you can see, I just sent 1, and if you take a look at the receiver virtual terminal, we have 1 there, and the transmitter terminal showing that toggled load 1. That is, load 1 has been toggled. And if you watch the first load, you'll see that the relay has been triggered. So it's now connected to the NO, which is the normally open. So if I should send 1 again, that's going to turn off the load, just like that. So 1 turns the load on and off. Likewise for the second one, I'm going to send 2. So 2 turns the load on, turns it off, turns it on again, and turns it off. So that is all for this video. Now next video, I'll be explaining the program that is used to achieve the aim of this project. Thanks for watching. I'll see you in the next video.